Okay, so area of a parallelogram is base times height. The base in this scenario is 5, and the height is 4. 4 times 5 is 20. Check. And then even if you have a super slanty parallelogram, you need the height from the top to the bottom, even if they're not lined up on top of each other. So in this case, our height would be 3.5, and our base would be 2. So Jack, what is the area of example 2? Yep, 7 what?
Centimeters squared.
Centimeters squared. Nice. So here's what we got to think about. When sometimes it's our parallelogram is going to be oriented in a way that we have a hard time seeing what our height is. And I'm going to have Andrew, can you just read the instructions for example 3?
Find the length of DE to the nearest tenth by using 2 different calculations of the area of ABCD.
So we're going to find the area of our parallelogram here, our ABCD. Okay, but one of the issues is that it's oriented in a way, I'm like, wait, I can't see what my height is supposed to be. So if you, come on, there we go. So if we rewrite ABCD and reorient it, so it was like this, where we had A, B, C, and D. And we just rotated that bad boy so that all of our coordinates rotated around. Then we can see that from D to A is 13. So we can use 13 as our base. And what's the distance from AD to CB? 9. So we can see that our height is 9 and our base is 13. We're going to find the area with those dimensions. And if you want to do mental math, because it's fun, I don't know what 9 times 13 is because I'm not that smart, but I do know what 9 times 10 is. That's 90. And I know what 9 times 3 is. That's 27. I add 90 and 27 together to get 117, and that's inches squared. All right, so now we're going to come back to this guy. A, B, C, D, all normally oriented. We need to find DE, and that's our height of our parallelogram when it's oriented this way. We know that our base is 9.4, and we actually know that the area is 117. So we're going to say 117 is equal to our base, 9.4, times our height, which we don't know, DE. We're going to divide both sides by 9.4. Now I would struggle to do this with mental math, so I'm going to pull up my buddy calculator, and he is going to help me out with this problem. 117 divided by 9.4. And he's 12.44. I'm going to go back, so ladies and gentlemen, promise me, anytime you get a crazy decimal number, you'll go back to the instructions and figure out what they're trying to ask you to round to. Some of you guys lost a bunch of points on that trigonometry test because you weren't paying attention to round to the nearest tenth. And every now and again in geometry that happens to us. So we want to round to the nearest tenth. So we're going to say 12.4 inches. Because 12.44 rounds to 12.4. All right, so this is going to be super fun. This is the reason the parallel formula works. Let's go ahead and have Peter read what we're going to be doing with this little shape right here. How? Start with how.
How are the area formulas for parallelogram and a triangle the same? How are they different? Explain using pictures.
All right, so we're going to look at the area formula for a parallelogram and a triangle. So we're going to start with this parallelogram here, and we're going to drop a line from diagonal to diagonal. We cut our parallelogram in half if we cut it along its diagonal. If this side is A, this side also has to be A because it's a parallelogram. If my top side is B, the bottom side also has to be B. So this is the picture part of our problem. So I'm going to take this bottom triangle, and I'm going to separate them out. I kind of like the long side to be on the bottom, so I'm going to rotate him because I can. Okay. Actually, let's have, we should have the base be the bottom. Okay. I'm okay with that. The base will be the bottom. So you guys can see that this is just the same triangle. That's the bottom part of here. If we rotate him, he is the same as that top triangle. So it's like we have two triangles living inside of the parallelogram. Okay, so here's our triangle here. We have our base. And the height of this triangle, come on, buddy, is going to be here. So what is the area of this triangle? What is the area of any triangle? Base times height divided by 2. The area of any triangle is base times height divided by 2. The area of the parallelogram here is, let's put this H in there, is base times height. Okay, so the areas of the parallelogram and the area of the triangle are the same because they both have base times height. They are different. What makes them different? What makes these two area formulas different? Dylan?
One divides by 2 and the other doesn't.
Yeah, one has a divide by 2. And that's what separates them. Awesome. Okay, so how are they similar? How are they different? Check. Explain using pictures. algebra and words. So let's go ahead and use some algebra on this. So I'm here to tell you that the area of a parallelogram is equal to 2 times the area of a triangle. This is how we're going to use algebra. Do you agree that 2 triangles come together to make the area of a parallelogram? Can we see the 2 triangles in our parallelogram? Are you guys visualizing that? There's 2 triangles in there. So the area of one parallelogram is equal to the area of 2 interior triangles. So the area of the parallelogram is equal to 2 times base times height divided by 2. 2 on the top and 2 on the bottom cancel out. So this kind of looks like 2 over 2 times base times height. 2 divided by 2 is 1, and the area is base times height. So the area of a parallelogram, even though it's equal to the area of a rectangle, it's not the rectangle relationship that makes the area of a parallelogram base times height. It's how it's related to the triangle, and the fact that it's double the triangle that makes it base times height. Just for fun. All right, you guys are going to get some pretty wonky shapes. We're going to have to put it together and find some areas. So, Kai, what are the 2 shapes rolling around in exercise 4?
Triangle.
Yeah, so we got the area of a triangle and the area of a square. And when we add those together, it's going to equal our total area. Super important, you guys, they're going to give you a bunch of crazy shapes. For your accounting purposes, you have to keep track. Just putting this down on your paper will help you when you dive in and your elbows deep into the area, coming back here and realizing I have to add the areas together will help keep you on task. So let's find the area of this triangle first. Let's put the area formula down. 1/2 base times height. Justin, what's the base of this triangle here?
6.
6. If this is a square, all the sides are 6, then that means this base of our triangle is also 6. So it's going to be 1/2 6 times 8. 6 times 8 is 48. 48 divided by 2 is 24. So Dylan, after I do this problem, I'm going to come check to see what you have on your paper. And let's make sure if you want to play catch up, we do it now before we get
I'm already done with the problem.
on to the next step, okay?
Okay.
So 48, half of 48 is 24. You can also do it where we take half of 6 is 3. 3 times 8 is 24. Either way. Okay. So now we have the square, and Merg, if we do base times height for the square, what are we going to multiply together to find the area of the square? Yeah. 6 times 6, and that's 36. And then Jesse, finish us out here. What is 24 plus 36?
60.
Yeah. So it's 60. And Dylan, help us out. What are our units on this problem?
Inches squared.
Inches squared. Perfect. Okay. And graph our lines. That's definitely an Algebra 1 skill. You guys got tested on that last semester. Okay, so we're going to graph the line y equals x. This is a line with slope of 1/1, and it starts at 0. So it goes up 1/1. I put a dot because I am too lazy to get out a straight edge, And the only way to keep a straight line straight is if I can go dot to dot. So we're going to graph the line y equals x. Some of you guys are probably thinking, isn't it faster just to have a straight edge and not do the dot to dot? Because it's taking me forever to put these dots. 6 of 1 and half a dozen of the other. Okay, the line x equals 0. We did a bunch of these with our lines of reflection in chapter 9. X equals 0. Anything x equals is a straight up and down line. And at 0 is right here. I don't need help keeping that line straight because I've already got a line that does that. Y equals 6. Anything y equals is a flat line, and it goes through y-intercept of 6. That's this line right here. And once again, I don't need a straight edge because I already have a straight line to guide my line. Okay, I'm going to outline the shape that is created for these guys crossing together. We'll do that with maybe like highlighter. I'd like a green one. So it's this shape right here. We're supposed to use coordinates. I definitely know I can do this without coordinates, but because I know the learning objective, we're going to stick tight to that and look at the coordinates here. If I am writing the vertices, the coordinates of the vertices, one is at 0, 0. This one here is at 0, 6. And then this one here is at 6, 6. Now, if we weren't lined up super exact, we're finding the area of this, but I'm going to put perimeter too. We're going to do a bonus one here because our learning objective has use coordinates to find perimeters. So we're going to do a bonus. Bonus track. This is like Taylor Swift bonus track. It's that just white noise. Just #1 selling. So if we wanted to find the area of this triangle, it took me probably about 30 years to remember that when we have a right triangle, the base is one of your legs and the height is the other leg. So in a right triangle, the base and the height are just on the sides of your triangle. So I would always try to find the height, and I'm just not that smart. So the area of this triangle is base times height divided by 2. I'm just going to count. My base is 6, and my height is also 6 on this one. 36 divided by 2. Anytime you're fussing with a graph, we call the units units. And when we're having area, we just write unit squared, u squared. Okay, so here's your bonus track. We're going to find the perimeter. So in this case, the perimeter is going to be B plus H. And then I'm going to call this guy C. Anybody know why I'm calling that guy C? Jack's got it. Because it's the hypotenuse. We have a right triangle. Some of you guys got tripped up on that on your trigonometry test. You're like, I don't know what that is. Yeah, but you have both A and B. You just use Pythagorean theorem to find it. Okay, so we know that the base is 6. The height is 6. What kind of right triangle is this? I'll give you a hint. This is not the answer.
45, 45, 90.
Yeah. 90. Yeah, it's a 45, 45, 90. Anytime you have an isosceles right triangle, boom, you're 45, 45, 90. So 45, 45, 90. What is the hypotenuse? How do I go from 45 to 90? What's my multiplying factor? 2. We know it's Pythagorean theorem. Got a bunch of roots running around in Pythagorean theorem. And it's actually the leg times the square root of 2. So the perimeter of this guy is going to be 12. Let's get my math right. So 6 plus 6 is 12 plus 6 root 2. So you can use the coordinates. If you wanted to use distance formula to find that, we can also use distance formula. Real quick before you put this away, let's write the distance formula down. I'm super afraid that you guys are going to need the distance formula and we won't have practiced it. So the distance formula is the square root of y2 minus y1 parentheses squared plus x2 minus x1 parentheses squared. This case we didn't need it, but if we're kind of in the middle of a weird graph, we might need the distance formula to find the perimeter. Okay, is that it, guys?